Today we are talking about the worksheet called Learning About Lingos. Okay, learning about lingos. Let's start with number 1. Notice please that I have a piece of notebook paper up here because you know we don't have enough room on this page to do our work. So 2x plus y minus 3z equals negative 1. Let's zoom out just a little bit. 3x minus y plus 2z equals 4. X plus 2y minus z equals 5. Always check your signs, recheck them after you copy them, because if we mess up, typically one of the ways that we mess up is a missed sign. Okay? So, I've checked mine. I'm satisfied that it's good. Okay? So tell me, which variable do you think we should cancel first? Can you tell me why you think we should cancel the y's? Top two are already opposites, so I could cancel that out easily. If this is a positive 2 and this is negative 1, wouldn't I just multiply this one by 2 to cancel that one out? So pretty simple, right? So here's my question for you, however. Could you give me a really good argument for canceling out the x's? Could you argue with me that it would be fine to cancel out the x's? Give me the argument. What could you do? Multiply the bottom one by negative 2. Combine it with the top one. That would cancel out the x's. Multiply the bottom one by negative 3. Combine it with the middle one. Cancel out the x's. That wouldn't be too difficult either, would it? Could you give me a legitimate argument about canceling out the z's? So the point I'm trying to make is, it doesn't matter, right? Some of them are easier than others. Probably the most difficult one of all of these would be the z's, right? Because eventually I'd have to multiply this bottom one probably by a negative 3 to make it a positive 3, and we don't like to multiply stuff by negatives. We always mess up. Not always, but we're not comfortable with that, are we? Okay? So, you said you want to cancel out the y's, so we'll cancel out the y's. All right? The first thing we're going to do to cancel out the y's is we're going to combine the top two equations, right? So if we have 2x plus y minus 3z equals negative 1, and 3x minus y plus 2z equals 4, what do I get when I combine those two equations? 5x, that's 0, minus z equals 3. Okay so far? Is it okay? Okay. Now what? We got to use a different combination of 2, right? We're going to use the top 2. Which 2 should we use now? Kelsey says top and bottom. Does anyone disagree with her? Besides me? Now, can you use the top and bottom? Absolutely. Is that the easiest choice? No, middle and bottom are already opposite signs, right? So I'm not going to have to worry about multiplying by negative. But Kelsey, I'll be happy to do top and bottom if you want. Okay? So if we're doing middle and bottom, I have to multiply this one by a 2. Good. So I get 6x minus 2y plus 4z equals 8. And then I have the bottom equation, x plus 2y minus z equals 5. Okay? Okay so far? What? Okay, good. Combine these two and I get 7x, 0, plus 3z equals 13, right? So then I have 5x minus z equals 3 from right there. And then I also, from right here, have 7x plus 3z equals 13. What should I try to do now? Cancel out the z's, right? If I'm going to cancel out the z's, what do I have to do? Multiply the top by 3. Excellent. 15x minus 3z equals 9. And then I have 7x plus 3z equals 13. We good so far? Combine these two. 22x equals 22. What's x equal? 1. Where should I go? You want to go the 5x? Okay. So from right up there, right? 5 times x, which is 1, minus z equals 3. So 5 minus z equals 3. If I subtract 5 from both sides, I get negative z equals negative 2. So z equals 2. And if I know x and I know z, I can go back to the beginning to find y, correct? Which one do you want to use from the beginning? Last one? Okay. Last one, x, which is 1, plus 2y, minus z, which is 2, equals 5. So 1 minus 2, so 2y minus 1 equals 5. So if I add 1 to both sides, I get 2y equals 6. So y equals 3. God bless you. One minus 2 is negative 1. And they're on the same side of the equation, so I just combine those two values. Okay? Good question. So what's my answer? How are we doing on this stuff? We've been doing it for a couple days now, so hopefully we're doing pretty decent on it, yes? Okay. I need to show you guys something. I'm going to go a little off topic here. I know you never mind when I do that. Do you guys know what a matrix is? Not the movie, not the movie. Do you know what a matrix is? A matrix is a rectangular array of numbers. Okay? And I want to show you something really quickly. So just watch. I don't want you to do anything yet. Okay? Just watch for a second. I know this is so exciting. You're doing fine. This is the day where you hate me. Traditionally. Because after all of this, a whole page of work, I show you how to do it in the calculator. Because look, 1, 3, 2. 1, 3, 2. Okay, so look, let me show you what I did. Go back to the original problem. If we go back to the original problem, look at just the numbers in front of the variables, which are called what? Vocabulary word? Number in front of the variable? Yes, coefficients. Okay, I know. Some people actually did, so that's good. Okay, 2, 1, negative 3, negative 1. 2, 1, negative 3, negative 1. 3, negative 1, 2, 4. 3, negative 1, 2, 4. 1, 2, negative 1, 5. 1, 2, negative 1, 5. I can feel waves of hatred coming my way. So first thing I want to say is get over it, okay, so that I can teach you how to do this. Now, first of all, I need to make it very clear. This is not the only way to do it in the calculator. There's probably like 4 ways. Okay? I'm going to show you one way today and one way on Monday. All right? The one way today that I'm showing you, do you see these letters right up here? R, R, E, F. Okay? Go to menu. Do you see number 7? We are talking about matrices. For the record, it's one matrix, multiple matrices. That's the plural. We don't say matrices, because then I just make fun of you. Okay? Mostly to your face, so don't worry about that. So we choose number 7. Look at number 5. Forget the numbers, it's the words that are important. Okay? Reduced row echelon form. Reduced row echelon form is the way we're going to do this today. The way I'm going to show you in the calculator today. Okay? Reduced row echelon form. So choose number 5. See how it puts on your calculator RREF and open and closes a parentheses? Can you see the closed parentheses there? It's real light because it's not sure if you're ready to close it yet. Okay? We need to now create a matrix to put in there. How do you think we would do that? Menu. Try menu first, right? Go back to matrix. Oh, look at number 1. Create. So here's the deal. Okay? The matrix that we need to create, well, we need to create a matrix first of all, so we need to choose matrix. Okay? When I put it in the calculator, it looked like this. 2, 2, 1, negative 3, negative 1. 3, negative 1, 2, 4. And 1, 2, negative 1, 5. Okay? That's what it looked like, right? Notice, please, 1, 2, 3 rows. So on our calculator it says how many rows? Well, delete the 2 and put a 3. If you try to use the up and down arrows here, go ahead and try and see what it does. It changes the number of rows. That's not what I'm trying to do. I'm trying to get down to here. What do I press to get down to here? Tab. 1, 2, 3, 4 columns. Okay? So delete and make that a 4. Either press tab to get to OK or use your arrow, right? Move your little mouse arrow thing around until you get the mouse to come up and then press OK. Or maybe actually press OK. Is yours working? Mine doesn't like me today. Okay. Oh, okay. Well, now that I've already written down my original matrix, my starting matrix, that's what I put right here. Go ahead and enter that in, please. I know it's the one we just did. I know you already know the answer. I'm trying to get you the skills. Got it? And when you press enter, what happens? So you had a starting matrix, and the matrix you got out looked something like this. And in fact, not something like this, but exactly this. Right? So, to be clear, I need to make sure you understand how to get the answer out of this. Right? If we go back to this, which takes us back to the original equation, what went with the 2? An x. So this first place is a 2x, really, right? And this second place is a 1y, and this third place is a negative 3z, and then comes the equal sign, and then comes the constant, right? Well, if we did that here, look what happens. The first place is an x, the second place is a y, the third place is a z, and then the equal sign and the constant. What is 0y? 0. What's 0z? 0. What does this actually say? X equals 1. If this is x, and this is y, and this is z, and this is equal sign, 0x is 0, 0z is 0, what does this actually say? Y equals 3. X, y, z equals, that's not there, z equals 2. Can you read it? Good. Okay? So what do we have to be very careful of when we enter things into our matrix? Say it again. Signs, first of all, absolutely. Okay? Second of all, what did you say? Putting in the right place. Okay? So this was all nice and pretty because we had our x and our y and our z and our equal sign and our constant, and our x and our y and our z and our equal sign and our constant, and our x and our y and our z and an equal sign and a constant, right? But look at problem number 6 on your worksheet. Is this in the right form? Oh, sorry, that's 5. We could look at 6 too. It's not in the right form either, is it? Okay? You have to make it where it's x and y and z and then the equal and then the constant before you can put it into a matrix. Okay? So like on problem number 5, this first one, what would I have to do first? I have to add 2z to both sides, right? To get it in the right order. Is everybody clear about that? Okay, just to be clear, you know how strict I am on work? You got to show it, right? Well, if we're doing everything in the calculator, we still have to show some work. All right? So you're going to write the problem down. Actually, it's already on the page. Here you go. Okay? So on your notebook paper, you're going to write down your initial matrix that you put in. You're going to write down the matrix the calculator gives you out, and then you're going to write your answer. Got it? Initial matrix that you put in, the matrix you get out, and your answer. That's what I expect to see on your work. Fair enough? Okay. There's been some people confused about this, so let me make this very clear. When I give you worksheets like this that has these little silly problems on it, I could not care less about those problems. I would try to care about it, but I would not succeed. Okay? I don't care if you have these answers down here. If you want to, that's great. The math is what I care about. The math is what I expect to see. The math is what I expect to see work done. Fair enough? If you have these, that's great. You might learn something new by them. Or learn a little phrase or a quote. Okay? But the math is what I'm worried about. You have about 10 minutes or so, 15 minutes until the bell rings for lunch. If I were you, I'd try to get all the rest of the 10 that we didn't finish done before you leave. Otherwise, maybe I'll see you after school to finish on the calculator, or maybe I'll see you before school Monday to finish on the calculator. Because I don't want you to have to do these by hand. That's your other option. Got it? Any questions?